Good morning, dear students. My name is Ferhan Mazher, and today is 21st December 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Cambridge O Levels of Physics 5054. Today, we have set our hearts to solve an ATP paper. We call it Alternative to Practical. This is paper 4, and we have selected October-November 2018 4-1 paper. This ATP paper belongs from the zone 1, or you can say this is from the variant 1. The time allowed for this paper is 1 hour. So let's start this paper. October-November 2018 4-1 paper. 1 hour is allowed. We call it paper 4. The first question is showing up on your screen. A teacher demonstrates convection in a liquid. She uses a glass tube as shown in the figure 1.1. The tube is filled with water and left to stand for 10 minutes. A purple crystal is then placed in the mouth of the tube. This crystal dissolves and makes the water around it turn purple. The tube is then gently heated as shown in the figure 1.1. So here, this is figure 1.1. So this is a tube of glass and it is filled with water. And here they have placed a purple crystal and here they are gently heating it. So obviously the water here gets hot and the convection currents are set up. So they will, from here, the water will go up. From here, the water will go down. And this way the convection currents will set in this tube. And when the water convection currents will move like this purple crystal, the color will also move with the water. Because you cannot see the convection currents, but because of this color, you will be able to see that those convection currents, how they are moving. Suggest why the water is left to stand for 10 minutes before placing the crystal in the tube. So when you put the water in the tube and before putting the crystal, we don't want because when you have touched the tube, the water will be disturbed, it will be moving. So to let the water become still and you let the water to settle before you place the crystal. Okay, so that's why we give it some time to the water, so the water becomes stable, or you can say the water becomes still. So that's why the water is left to stand for 10 minutes before placing the crystal in the tube, is allow the water to be still. So 1 mark question. Then their question is, it says when the water is heated, it is heated gently. Suggest why. So when you are heating the water from here, you heat it, very mild heat is given, you heat it gently. The reason is because if you give it excess of heat, what will happen? The water here will start boiling and the color will be mixed in this water very quickly. So you will not be able to make that observation of the convection currents. So we want this process to happen slowly. So my answer is water might boil and color will spread too quickly in the tube. Okay, so that's why we are heating it gently. Okay. Then the C part is coming up on your screen. He says, question number 1, C part. On the figure 1.1, draw an arrow to show the direction in which the purple color moves through the water. Okay, so this is from here because we are heating, so the water convection currents are moving in this way. So the color will also move in this way. This is like clockwise direction. So let me show you from here. You can see with the red color arrows I have shown here, that shows that how the purple color will spread in the water. So let's go to the next part. Okay. State one safety precaution the teacher should take in this demonstration. There can be different precautions which the teacher should take. For example, they should wear safety goggles. They should be wearing the safety screen. They should wear gloves while they are handling the crystals, these purple crystals. So you have to write one of them. I have written, he should wear safety screen and wear gloves while handling crystals. You have to only write one option. So we are done with the question number 1, I think. Yeah, we are done with the question number 1. So let's have a look at the marking scheme. So here is the marking scheme. Okay. So pause the video and take your time, have a good look at this marking scheme. I always tell you, it is very important to, whenever you solve a paper, it's very important to check your answers and match them with the marking scheme. So pause the video and have a good look at the marking scheme and check that if our answers are right. So question number 1 is done. Okay, so we are going to the next question. Next question is question number 2. A student conducts an experiment with a glass ball and a metal ball. Figure 2.1 shows the apparatus he uses. The glass ball is placed on a cloth covered with bench at the bottom of a slope. The metal ball is then released from the top of the slope. It rolls down the slope and then hits the glass ball. Okay, so what's happening here? Here we have a ramp. Here we have a metal ball. This metal ball will be released from here. It will roll down the slope. And here we have a glass ball. This metal ball will collide with this glass ball, and this glass ball will obviously roll on this horizontal table. We have also placed a cloth on the table. So this glass ball will move from here and will come here. So he says the metal ball is released from a vertical height h above the bench. After the collision, the glass ball moves a distance d along the bench. So this is the height of the metal ball. This glass ball will move from here to here. So that's the d, and that is height h. On the figure 2.1 show the height h. On the figure 2.1 show the distance d. So these are the first two questions they're asking you to do. Okay. So here you go. So you see, this is the height from the metal ball, from where the metal ball is released. This is the height from the top of the bench. And from here to here is the distance covered by this glass ball. So it's a 1 mark question. Hopefully you understand. You have to mark the height and the distance moved by the glass ball. Okay, so suggest a piece of apparatus to measure these two lengths. Okay, so if you want to measure these two lengths, you can use meter rule. Yeah. Okay. If we want to measure these lengths, the simple apparatus is meter rule. You can measure. You can use the meter rule to measure it. Okay. Then the fourth part, the experiment is repeated. The glass ball travels the following distances: 23.5 centimeter, 20.8 centimeter, 22.3 centimeter. Calculate the average distance traveled. Okay, so if you want to find out the average distance traveled, you add these three distances, and whatever the sum is, you divide that sum with 3. You will get the average distance. Okay. So average distance is equal to 23.5 plus 20.8 plus 22.3 equals to, and that will be whatever will be the answer, you divide with the 3, you get 22.2 centimeter. So the average distance traveled is 22.2 centimeter. The initial gravitational potential energy E of the metal ball at the top of the slope is given by E is equals to mgh, where G is 10 Newton per kg and m is the mass of the metal ball. The metal ball has a mass m of 0.0081 kg. The height h of the ramp is 0.120 meter. Calculate E, giving your answer to the two significant figures. Okay, so here we have the mass, and which is 0.0081 kg, G, which is 10 Newton per kg, and H is this 0.120 meter. Just put these values and do this calculation. Okay, so let me show you. Okay, so E will be equals to in your calculator mgh, and you put just the values of m, g, and h. So 0.0081 into 10 into 0.120, and when you enter these values in your calculator, the answer will be 9.72 expo minus 3. So if you convert this scientific notation into the ordinary notation, the decimal will move 3 steps to the left. So your final answer will be 0.00972 joules. And because we want the answer in two significant figures, so it will be 0.0097 joules. So hopefully you understand. And that was the fifth part. Okay, so after the fifth part, we have, yes. The student extends the experiment by using metal balls of different masses. The glass ball does not change and H remains constant. The results are shown in the table of the figure 2.2. So the mass of the metal ball is gradually increased. So when obviously you increase the metal ball's mass, its potential energy will also increase. So here we have two blanks here. Here the energy and the average. Complete the table for the metal ball of mass 0.0081 kg using your answer to the A fourth part and A fifth part. So we have found A fourth part and the A fifth part. In the A fourth part, the answer is 22.2 centimeters. And here it is 0.0097 joules. So 0.0097 joules and 22.2 centimeters. You just have to put these values in that table. So that was question number 2B, first part. Hopefully you understand. Okay, now their question is, okay, we are done with the table. Second part is on the figure 2.3, plot the graph of D average in centimeters on the y-axis against E joules on the x-axis. Start both the axes from the origin. So we have to draw D average. So this D average is supposed to be on the y-axis, and this energy is supposed to be on the x-axis. And you know, this is going from 0.0036 to 0.0228. So let me show you that graph which you have to draw. Let me reduce the size so you can see the whole thing. So this is that figure. Okay. This is that figure. This is that actual the graph which we have to draw. So let me show you. So here, first of all, I'm going to, label the axis. So on the x-axis, we have energy. So 1, 2, 3, 4. 4 centimeter is 0.01. Okay, so here you will have 0.02. Here you will have 0.03. On the y-axis, we have D average, and because the here 2 centimeters are representing 10, here 20, 30, 40, 50, 60 and 70. Okay. Then I will plot those points. Okay. So you can see here I have, by using this table, energy is on the x-axis and d average on the y-axis. I have plotted these points. This point, this dot, this dot, this dot. And then they ask us to join them with a line curve of best fit. So I have tried to draw a curve of best fit here. So see, I have tried to draw a curve of best fit. Okay. So this is how you draw that graph, and let me show you. So this is the question on the figure 2.2. Plot the graph on d average centimeter on the y-axis against E on the x-axis. Start both axes from the graph origin. Draw the smooth curve of the best fit. Suggest a reason why the student covers the bench with the cloth. So you see, we have covered this bench with the cloth because when you put a cloth here, the cloth will have more friction as compared to the surface of the table. So the cloth will not let these balls to roll off or drop down from the bench. It will stop the balls. Okay, the balls will cover less distance. So this is the reason why we have put a cloth there. So let me show you my answer. Okay, so this will increase the friction and the ball will not roll off the bench. So that's the question number 2C part. Oh, okay, so we are done with this question. Let me show you the marking scheme. So here we go. The marking scheme of the question number 2 is showing up on your screen. You can pause the video and you can read the marking scheme. You can check, you can match your answers with this marking scheme. Pause the video and have a good look at this marking scheme. To watch, to learn, to read, to compare your answers with the marking scheme is very, very important. Okay, so we are going to the next question. A student is given a quantity of liquid in a beaker and asked to determine the density of the liquid. Density is found using the equation density is equals to mass divided by volume. He pours the liquid into a measuring cylinder. Figure 3.1 shows the measuring cylinder after the liquid is added. So here's that beaker in which the liquid was, and then you have poured the liquid into the measuring cylinder, and you can see that we can read how much is the volume of this liquid. So on the figure 3.1, mark the position of the student's eye when he is reading the measuring cylinder. The position of the eye should be on this level. It should be on this level. Okay, this the lower meniscus, it should be on that level. So let me show you. I have drawn that. Okay. So you can see that we have drawn the eye on the lower level of the lower meniscus. The eye should be leveled here. Okay. And then we have a question. He says, explain why this position of the eye reduces the error when taking the reading. So when the eye is at this level, you're exactly perpendicular to the scale and your eye is leveled with this position where the reading is, where you have to read the reading. It reduces the chances of the parallax error. Okay. In this position, eye will be leveled with the lower meniscus and perpendicular to the scale, so there will be no parallax error. That's the reason. Then the question is, state the volume of the liquid in the measuring cylinder. Okay, so the volume in the measuring cylinder, you can increase the size. You can see it is 78. Lower meniscus is at 78. So 78 centimeter cube. Then he says, state the name of another piece of apparatus the student needs to in order to find the density of the liquid. After knowing the volume of the liquid, we need to know what is the mass of the liquid. So if you want to measure the mass of the liquid, we will use electronic balance, or you can say balance or band balance. Okay. So we need a balance to measure the mass. Okay. So B 78 centimeter cube is the reading. So state the name of the piece of apparatus. Student needs a balance. Okay. So the next question is explain how he uses this apparatus in this experiment. So what they will do, they will measure they will put the beaker on empty beaker on the balance, and they will note down the mass. Let me call it M1. Then they will pour water into the beaker, and with the water they will measure the mass of the beaker. They will call it M2. Then they will subtract the M1 from the M2, and that will give you the mass of the liquid. Then they will pour the water from the beaker into the measuring cylinder, and they will note down what is the volume of that water. And once they know the water mass, and they know the volume of that liquid, or then they can use the formula that the density is equals to mass divided by volume, and they can find out the density. So this is how this apparatus should be used. Okay, so let me show you. Okay, so measure the mass of the empty cylinder M1, measure the mass of the filled cylinder M2. Mass of liquid is calculated by M2 minus M1. Okay. Now, he says the student's eye is at the correct position when taking the reading. He calculates the density from his results. His teacher says that the value he obtains is different from the actual value. Suggest a reason for this. There can be many reasons when you are measuring things. For example, some water might be left in the beaker in the form of drops with the walls, and there might be, when you pour the liquid into the measuring cylinder, there might be some splash, and another thing can be that there might be some zero error in the electronic balance or balance which you are using to measure the mass. There can be many reasons. So let me show you. Some drops of water are left on the walls of measuring cylinder, so that due to that maybe the volume is not that much, because when you pour the water, some water drops are left on the measuring cylinder's walls. So let me show you the marking scheme. So marking scheme says, I especially want to read these two answers. Find the marking scheme for the question number 3 is showing up on your screen. You can stop the video, you can pause the video, and you can have a good look at these marking schemes. He says find mass of empty measuring cylinder or beaker, tears, zeros, and then find mass of cylinder, beaker plus water, or find mass of empty cylinder or beaker and mass of cylinder and beaker plus water. Subtract to find mass of water, uses equation to find density. Then he uses here, when I wrote the answer, I have in my explanation I said that this part I did not wrote further that use the formula of the density mass divided by volume, and you will get the density. But you are supposed to do that. Okay. From the measuring cylinder, he will measure the volume, and then he will use the formula density is equal to mass divided by volume. And by using that formula, he can calculate the value of the density. So write those two lines here. Okay. Where's the marking scheme? Okay. Then it says drops of water left in the beaker for measuring cylinder, splashes, any sensible practical reason to give a different reading, zero error on the balance. Okay, so this is how you do the question number 3. The marking scheme is showing up, and please read this marking scheme carefully. Okay, so let's do the next question. Uh, a student investigates the resistance of equal lengths of different wires. The wires are made from the same material but have different diameters. Resistance can be found using the equation. So the wires are of the same material. The wires have same length, but they have different diameters. So the resistance is the formula is resistance equals to voltage divided by current. The student uses the circuit shown in the figure 4.1. Okay. So here the length is 3.3 centimeter, which is of the wire, which is in use. State the name of the piece of apparatus that the student can use to measure accurately the diameter of a wire. If you want to measure accurately the diameter of the wire, we use micrometer. The student takes readings of voltage and current immediately after he switches on the circuit. Suggest a reason for taking the readings immediately. You see when current will start flowing through the wire, and due to the resistance of the wire, the heat is produced when the current flows through the wire. So when the heat is produced, the temperature of the wire will increase, and that will increase the resistance, and that will automatically change the amount of current flowing in the circuit, and that can alter our results, because due to the heat produced, the resistance of the wire will increase. So that's why he immediately takes the reading and switch off the current. So that's question number B and A and B. Let's have a look at our answers, and then we can move to the next part. Okay, so here we have micrometer. Otherwise, wires get hot and resistance might change. Okay, so then we have the next part. He says, let me increase the size. He says the figure 4.2 shows the ammeter and the voltmeter when a wire with a diameter of 0.15 millimeter is used. Okay. Now, what's the reading on the ammeter? The diameter is given here. Remember this. We can find the radius from here. And what's the reading here? It's 0.1, 0.2, 0.3, 0.4, 0.5. So it's between 0.3 and 0.4. So it will be 0.3, 0.32, this will be 0.34. So the reading is 0.34 ampere. So the reading is 0.34 ampere on this ammeter. Okay. Now, the reading on this voltmeter is, this is 1, 2, 3, and 4. And this will be 2.2, 2.4, 2.6, 2.8, and 3. So the reading is 2.8 volt. The reading is 2.8 volt. The reading is 2.8 volt. So you have to just note down these readings. Okay. So then the next question is, the student repeats the experiment using a wire of the diameter 0.24 millimeter. The voltmeter readings does not change. Figure 4.3 shows the new ammeter reading. The voltmeter reading is not changing, but the ammeter reading has changed. Now the reading is, this is 0.5, 0.6, 0.7, 0.8, 0.9, and 1, 0.8, 0.82, 0.84, 0.86. So the reading is between 0.84 and 0.86. So it is 0.85, 0.85 ampere. So the reading is, where do we have noted down that reading? Okay. 0.6, 0.7, 0.8, and 0.85. Okay. He says, complete the results of the figure 4.4 for the experiments for the two wires. Okay. The diameter of the first wire is 0.15 millimeter. So 0.15 millimeter here. The diameter of the second wire is 0.24 millimeter. So that will come here, 0.24 millimeter. The voltage in this is 2.8. So here 2.8, and the voltmeter reading here will remain the same. It does not change. The reading of the current has changed. So we will put both the readings of the current. We have already noted. And then we'll find the resistance. Resistance is V by I. So let me show you. So 0.15 millimeter diameter, 2.8 volt, 0.34 ampere. Divide the R is equals to V by I. So 2.8 divided by 0.34, and it will give you 8.2 ohm. And for 0.24 millimeter diameter wire, the voltage is same, 2.8, and the current is 0.85 ampere, and the resistance R is equals to the voltage divided by the current. So it will be 2.8 divided by 0.85, and it will be 3.3. 3.3. Resistance we have calculated by using a calculator. Okay. It says use your results to suggest the relationship between the diameter of a wire and its resistance. Okay. Diameter of a wire and its resistance. You can look. When the diameter is 0.15, the resistance is 8.2. When the diameter has increased 0.24, the resistance has decreased. It means when the diameter increases, the resistance decreases. That's their question. Use your results to suggest the relationship between the diameter of a wire and its resistance. So if the diameter will become larger, the resistance will decrease. As the diameter has increased, the resistance has decreased. Okay, so this is my answer. And okay. So by this question, we have completed that paper. Okay, so let's have a look at the marking scheme. Question number 4. So my dear students, pause the video, have a good look on the marking scheme of the question number 4. To check your answers with the marking scheme is very, very important. You can pause the video and you can have a look at the marking scheme. Okay, so now we are done with this paper. So my dear students, today we have done October, November 2018 for one paper. It's alternative to practical, paper 4. And I hope that you have understood that how this ATP paper is done. If you think this video has helped you to understand the concepts in this ATP paper, don't forget to subscribe my channel. Also share the link of this video into your Facebook accounts, into your Instagram accounts, and onto your Twitter account, because that will help me promote my channel, and that will be a great appreciation for me. So thank you very much, everybody. It's a pleasure teaching you all. So once again, thank you very much, and have a good day, and God bless you all.